CQRS, Command Query Responsibility Segregation. Think about a typical database application. It uses one model, one schema for everything. Writing new data and running complex reports. This is the CRUD model. This leads to a huge problem. Contention. The model optimized for fast writes is terrible for slow, complex reports. They clash constantly. Your application becomes a bottleneck. The solution? Stop forcing one model to do two totally different jobs. Welcome to CQRS, Command Query Responsibility Segregation. CQRS fundamentally separates the model used to update information, the command side, from the model used to read information, the query side. They become independent systems. We define a command as a request to change state and a query as a request to retrieve state. To achieve true separation, in CQRS both the models and the underlying databases are different, chosen to serve two conflicting masters: integrity and speed. Let's trace a transaction, starting with the command side, and see exactly how its model is built. The command side is focused entirely on integrity and validation. Its job is to ensure all business rules are met before any state change happens. The right model is designed for transactional integrity and is highly normalized. It uses many tables and foreign keys to prevent data redundancy and ensure ACID properties. This model focuses on what the system can do. The verbs: place order or update inventory. When a user clicks, the command handler acts on this model. The right database is usually a relational database, like PostgreSQL or SQL Server. This is the best fit for transactional integrity and the complex joins needed for validation during a write. Once the state is changed, the command side publishes an event, like order placed event. This is the signal to the entire system. Subscribers, like the read model builder, listen for this event and update their specialized data stores accordingly. Now, let's follow that event over to the query side. The query side is built for pure read performance and display needs. The read model is designed for query performance and is highly denormalized. It flattens and pre-aggregates data into simple structures. This model focuses on what the user needs to see: the nouns, order summary or product details. The read model builder picks up the event and transforms the data. The read database is often a non-relational, NoSQL database, like MongoDB or Elasticsearch. This is best fit for high-speed reads and storing those denormalized documents. When a user requests a report, the application sends a query that hits this specialized read database directly. Because the read model is already pre-built, the query is incredibly fast. That's the power. Two separate models with two separate databases optimized for two different worlds. But why go through the trouble of separating commands and queries? Benefit 1. Independent scaling. You can scale up your read databases, the query side, to handle 10,000 reads per second without touching your critical write master. Benefit 2. Optimized data storage. Use relational SQL for transactional integrity on the command side and use a flexible NoSQL database or search engine on the query side. Technology fit is prioritized. The primary trade-off is eventual consistency. The read database is eventually, not instantly, consistent with the write database. This means a user might see a tiny delay before their latest write appears on a read screen. For the massive performance gain, this delay is often acceptable. CQRS adds significant overhead. Don't use it for simple applications. It's only worth the effort when you have a high volume of transactions and a huge disparity between read and write load. Large e-commerce platforms, financial trading platforms, and business intelligence reporting are perfect candidates. CQRS empowers you to break the mold of the monolithic database, achieving a truly scalable, decoupled, and flexible system. This is Tech in 5 minutes, and I'm Ashish Kumar. Thanks for watching. Remember, the power of CQRS lies in its separation. Strong consistency for your writes and pure read performance for your users.